to APRIGF 2024, Resilience of the Internet Network Infrastructures, Day 3, August 23rd, from time 2:50 to 4 o'clock. All sessions are being recorded and transcribed for APRIGF records and will be made publicly available. All participants are reminded to follow the code of conduct. And now the agenda is about to begin. Please allow me to invite the host to lead us through the upcoming sections.
Okay, good afternoon, everyone. I'm Kenny Huang, Chair of TWIGF and Chair of APNIC. It's my great honor to chair this section. First, I'd like to introduce our three distinguished panelists. Starting from Seiichi, is from Google. He's going to introduce the Google Internet Resilience Design and also Engineering Planning. And the next one is Noelle from Internet Society, and she's going to introduce about from Internet Society perspective. The third one is joined online, Cheng. Is Cheng online available? Chi-Hu, can you turn on your mic?
Hi, yeah.
He's sleeping. Okay, thank you, Chi-Hu. Yes, loud and clear. So, wonderful, we have three very distinguished guests. And just simple reminder, this session is going to be very serious, technical oriented. So if you don't have technical comprehension, you better stay here a little bit longer. Okay, starting from Seiichi. Seiichi, would you like to introduce, starting from your presentation?
Okay. Greetings, everybody. My name is Seiichi. Thank you for the kind introduction, Kenny. I work at Google as a lead of Google's APAC peering strategy. And if this is the first time you've heard the word peering, please don't worry. I'll do a bit of explanation about a high-level explanation of how that works. And then, as Kenny's introduced, I can also talk about what the peering industry is doing to make the internet infrastructure more resilient and reliable. And we have some interesting initiatives ongoing as an industry. And I keep using the word industry because peering takes collaboration and cooperation to make things work. So it's I've been involved in this for many years, over 20 years. First, before joining Google, I was working at an ISP doing peering and network engineering related stuff. And then about 8 years ago, I joined Google, and I'm still in the network field, although less technical, and more related to strategies and policies, and it's been an interesting ride. So I'd like to share with you what we're doing in the space of peering as Google, but also as a peering industry. Should I go with the slides, or should
you might to show the slide?
Okay. Oh, there it is. Great, thank you. So I think I have a clicker here. And it's showing on this side. Okay, great. So I do have a few slides. And I did prepare slides just to try to make it easier. I know that some of this can get technical. I'll try to keep it as simple as possible by using examples. But if I get too boring, you do have the option to go to the mic and give me a clue that I don't understand, or if you have a question, please do ask. So internet reachability really depends on this thing called peering. And I believe there's a session that is happening sort of in the same like time frame that is about submarine cable systems, which is sort of the underlying infrastructure of the internet. But peering is really what connects us, when I say us, when Google to the rest of the world, and the rest of the world to Google or any other online services. And this diagram is just a quick example. And I'll take sort of a YouTube video as an example because I think that's sort of easy for people to understand. If a YouTuber, let's say, is editing a nice video and they want to upload that content to be viewable for everybody, what happens is that you'd be doing the editing at home or using your laptop, and then you're done. You want to upload it to the YouTube platform. What would that YouTuber do? Their house or their studio is connected to the internet through an internet service provider. Like this could be Taiwan Mobile or this could be HiNet. And that content gets uploaded to the YouTube platform by going through this ISP's backbone network. And maybe I should just like sort of point where, oh, interesting, okay. So I'm trying to go from left to right. Oh, this is like detective work. This is so cool. So a video gets uploaded, and it goes through the provider's backbone through their network where they have peering with Google. Google's network edge and the ISP's network edge is connected through this thing called peering. So that video gets to us through peering, and then it hits some of our servers, front-end servers that we have in our POPs. POPs are called points of presence, and they're usually in a co-location data center. Co-location means it's sort of like a hotel. I rent some racks in a facility. The provider also rents a rack in a facility, and we connect the fiber with each other, equipment, so that traffic can flow through. And then when it gets into Google's infrastructure, we don't keep it in this like edge data center. We bring it to one of our core data centers where it gets processed. In this data center in APAC region, we have one here in Taiwan. One of our first it is our first data center in APAC. We also have one in Singapore and Japan recently as well. So it goes to the data center where it gets processed and becomes ready for everybody to view. But I live in the United States. The content may not be really so useful if it's just sitting in the Taiwan data center. So it gets if it's really popular, it gets replicated to many different data centers where it becomes closer to the end user. So me, as an end user in the United States, my house is using Comcast as the ISP. So this is me. I click on a video. Oh, this is a new video. I want to watch it. And that request goes through the Comcast network, which will be peering with Google on the other side of the ocean and hits some of our front-end servers in our points of presence data center. And then this is a new video, so the content isn't here. I'm going to go fetch it from the data center nearby in the US West Coast, where I found the content. And then it goes back, and now I'm finally able to view that video. So in all of this, there are two different peering links that came up. One, that is where the YouTuber is uploading the video to the YouTube platform through peering. So it goes through the local ISP to Google, and then Google sort of carries it across to different locations, and then when me as a user would try to access it, goes through my ISP, local ISP Comcast, and it goes to Google's infrastructure and finally pulls the video. So peering really brings the whole world together by connecting different networks. And very simply put, in one drawing, my network connects to various ISPs and other content providers all around the world, and this is what we call peering. So in the peering industry, we've been focusing a lot on making the internet more resilient and reliable. There are three perspectives that I'd like to introduce today. One is about security. I think this one is the most difficult because it gets really technical. And then I'll also introduce about how we maintain redundancy in the world of peering. Of course, redundancy is a bit easier to imagine because you have like two cable systems or two fibers connected. One goes down, the other stays up. Seems pretty, intuitive, and you might think that everybody's, building their networks in such a way, but well, not always the case. And then lastly, and most important, the cooperation aspect of what the peering industry is doing. So you can have security, redundancy, I can put in all my efforts into this, but it's really not going to matter if I can't work together with ISPs or other cloud and content providers of the world. Am I going too slow? Is that right? Okay. 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 So first on security, I'd like to bring up a critical topic that the industry has been focusing on, and also Google has been focusing a lot on implementing routing security so that traffic, or in an example that I was explaining, a video being uploaded to me watching that video, it actually flows to the right place so that people can access that video. I mean, this doesn't have to be a video. This can be like an online content that is hosted on Google Cloud, the same thing. But there are basically three big risks that we see, and we have different ways to mitigate them. The first one is I make a mistake, and I somehow pretend to be someone else, and then I start attracting traffic that's actually supposed to go to some other site or some other video site. And users would have trouble accessing that other site. You know, they might be able to access YouTube, but they might not be able to access that other site because I've made a mistake. Now, does this happen often? Not thankfully not. We've been putting in a lot of efforts to prevent this, but I would honestly admit that we have made this mistake before. The second case is the other way around, where somebody else pretends to be Google and starts sucking in Google traffic that is supposed to come to Google is going to this other party. And what happens is that the end user is not able to access Google services. Does this happen often? It happens more often than we are comfortable with. Of course, it doesn't create like a whole big outage that you might see on the news, but we do see several incidents. Well, I shouldn't say several, like maybe one or two a year in a very small scale where certain regions are impacted by this activity. The third one is the most common, and this might be the most difficult to understand. I'll try to explain. Maybe I'll use an example. Let's say Google's platform has an API that calls some service that a third-party EC site is using. Google's platform services need to reach that EC service. But someone on the internet makes a mistake, or maybe with malicious intent, starts attracting and sucking in traffic destined to that EC site. It's not involving Google's infrastructure, but Google now has a hard time getting to that EC site. So the end user that's trying to access that Google service may only get part of that service served to them because my API is not able to access that EC site. So it's not directly involving Google, but a certain incident on the internet sometimes has an impact on Google services. And this is really the most common case that we see. It happens several times a year. And I can put in all my efforts into making my network secure, but if everybody on the internet isn't doing it, then the internet and users are still going to have like mediocre internet services. So, you know, I might have been scaring you, but there is a technology that's being rolled out to fix this problem, and it's called RPKI. This, if rolled out by many, will help protect against these kinds of incidents. And amazingly this year, I think we crossed 50% of registered, so this takes like, you know, I don't want to get too technical about this, but the first part of implementing this technology is to say, here is how my traffic should be routed. And in IPv4, I think in May, we crossed 50% of the internet routes having this appropriate registration that is uploaded and viewable for everybody to use. And this is great. And IPv6, I think, is doing even better. So the whole industry is trying to cooperate and collaborate to get this rolling so that everybody's network traffic is protected. It's a really great thing. And it takes the whole industry to make this work. Now, the second point that I want to introduce to you about is redundancy. This is a little bit easier to understand. When you have peering, when peering link connects one network to the other, did we lose video? I hope I didn't push anything. I hope we didn't lose the internet. So when an ISP and a content provider is interconnected using peering, you want redundancy. And redundancy can happen at multiple levels. Like, we can do this in multiple data centers, redundant data centers. We can do this in redundant cities. Or we can do this over multiple internet exchanges so that one goes down. At some level, it could be like a facility, data center facility losing power, or a natural disaster causing an outage to an area, a region. We want internet to be more predictable, reliable, and we also want the latency to be stable. That's the best thing. So having more peering will, in fact, help this. Even if you have cables connected, you really need to put in that peering configuration to make it redundant. And to do this, the industry, again, is cooperating. I may want redundancy, but if the other side doesn't want redundancy, then you don't have redundancy. So the industry has been working together. The internet exchanges, as I think Chihu will introduce later on, this has been a key part of the peering industry. And this is what exactly what Google has also put into our policy, that we require redundant peering at various levels. And the last one, cooperation is really, really important. Now, these photos are photos from a conference called Peering Asia. It happens once a year. Last year, we did it in South Korea. This year, it's going to be in Jakarta, Indonesia, in early November. This is where peering managers, peering experts get together and meet. We have meetings, but also we have a conference session. And what's interesting about the conference session is that the photo on the right-hand side is what we call a peering personal. So this is where operators of the network and the internet will come to the stage and introduce themselves. They'll say, I operate in ISP, I operate in these regions, and here are my business challenges. And so to solve those business challenges, I would like to set up more peering with everybody here. And the whole industry does this. And this is really great because we get to know each other. It's not really just the rock stars of network engineering that get up on stage. It's everybody gets up on stage, introduces each other so that we know who to work with. And if there's an issue, we know each other. It makes it easy for us to cooperate. The photo on the left is a tutorial session. We also do that to engage newcomers in the industry. So my last slide here. In summary, good technology is being rolled out and more infrastructure is being built. And so there's going to be more pairing, which will make the internet more reliable and resilient. And cooperation is happening at these events that I've introduced so far. Now, what the challenge is that we have these cooperation events and we try to get to work with each other, but not all players show up at these events. So, I've been lucky enough to be, able to meet a lot of ISPs around the world, but oftentimes the bigger players may not just show up at these conferences. And I hope that we are able to change that to bring more people so that we can cooperate with each other. And also, the reason why I'm here today is sort of my last point, complications these days in the peering space are often non-technical. Sometimes I feel kind of helpless in some of the incidents that I see on the internet these days. And I thought, I probably need to come to these IGF meetings and share what's happening in the peering space, and also learn what the governance audience is thinking about, so that we can work together, not just within the peering industry, but the peering industry can communicate with the governance audience, and together we can work towards making the internet more resilient and reliable. And with that, sorry, I hope I didn't talk too long, but this is sort of what's happening in the peering space.
Okay, thank you, Seiichi. I think it's very wonderful presentation, and it's more simple than what I expect. Okay, I hope you all understand what I try to present. And actually, Seiichi's slide also remind me the evolution of the APNIC. It's because the APNIC is starting from address allocator, then gradually evolved to become address policymaker, and eventually, such as PKI comes out, and that's what belong to NRO staff and IKF folks working together to define a standard, identify IR as a registry, PKI registry. So eventually, APNIC evolved itself, become a routing policy controller. So eventually, the role of internet governance regime keep evolving and keep changing as well. And I still remember Peering Asia has come from APX, right? Yes. And APX was the baby from Chihu, because at that time, he initiated that kind of initiative to form an APX. I formed another one, is the IPv6 initiative, so eventually become an IPv6 deployment section in the APNIC. Wonderful, thank you. So next to Noelle, you try to introduce from ISOC perspective. Thank you.
Thank you, Kenny. Hi, everyone. I'm Noelle, and I work with the Internet Society. I think let's get on with the slides. I will zoom out a little bit. Seiichi talked about a specific aspect of internet resilience, and what I was hoping to share with you is kind of a broader view of resilience in Asia Pacific. So let's not worry for now on where this data came from. I will explain later. But just to give you an idea of a snapshot, rather, of what the overall internet resilience looks like in Asia Pacific, you can see one takeaway here is that there's still room for improvement. We'll go into that in a little bit. Zooming out to Asia Pacific more broadly. So I'm focusing on Asia because a lot of, these visualizations is really based on the available data. And at the moment, Oceania is quite skewed because we have a lot of data on, for example, Australia and New Zealand, not so much on the Pacific Island nations, the smaller ones in the Pacific sub-region. So with Asia, we're more or less, if you look at it overall, we're more or less, we come second to Europe. But when you zoom into infrastructure resilience, which peering and internet exchanges are part of, then we go down the rank. We go down to the 4th, actually. So through this tool that I will explain a little more later, there's also an option to zoom into country statistics, or the status of internet resilience within specific countries. And I'm showing here Singapore, which scores the highest, 72% in Asia Pacific out of 100. And we see that there are really multiple facets to how we can possibly measure resilience. And what I'd like to highlight here is something that the Internet Society focuses on, which is internet exchange points. I won't go into that too much because the next presentation will dive into that. But I would like to basically tell you a little bit more about where this data comes from. So the Internet Society has a platform where we really collate and curate data from multiple sources, you know, GSMA, ITU, UCLA, for example, to be able to give you a visualization of the health of the internet. We present different aspects of it. There's a tab, for example, on, we have an IXP tracker that tracks the level of, how ISPs, internet exchange points scale in the region, what their status is like in each region, in each country, for example, market concentration. So lots of things. I invite you to go into that. But going into how we look at internet resilience. So when the Internet Society talks about resilience, we are really referring to the ability to maintain acceptable levels of service when in the face of challenges or faults. An example of a fault is, for example, a network outage, a submarine cable, for example. An example of a challenge is when you have spikes in demand for internet access, as we saw during COVID, because everyone was at home. Another example is when an emergency happens. So when you have a natural disaster strike. So it's really, we like to look at internet resilience not just as the ability to meet the current connectivity demands, but also to anticipate future demands from future uses of connectivity, as we are now seeing, you know, requirements for high bandwidth, applications that require high bandwidth. So I think, yes, I already mentioned that. Let me end here, and then the next presenter, Chihu, can go into the specifics of exchanges.
Okay, thank you, Noelle. Because you identified several acronyms, I don't know whether the audience are familiar with the term or not, but it's fine. We can leave to Q&A, leave it to the flow. And Chihu, you will be the next one. I'm happy to switch over to you.
Thank you. Do you see the slide? Okay. Yeah, I need your help to go to the next slide. Because I don't really have a lot of time left, so I'll try to go through it very, very quickly. Hope that you can have a bit more understanding about the basics, especially the terms about transit, peering, and IXPs. And as you may know, in fact, internet is a network of networks. User network connect to ISPs, and small ISPs connect to large ISPs, and then various networks interconnected with one another to form the internet. Next slide, please. And each network on internet, in fact, is represented by a number called autonomous system number, ASN. It's a globally unique number. APNIC is in charge of assigning AS number for the Asia Pacific region, and then the network operators use the ASN, use the BGP protocol to do the interconnections with multiple networks and form the internet. And networks with like portable IP addresses and also AS number, they would be more independent. They would be more portable, because they can freely interconnect with others. If you don't have these, you probably would rely just on your ISPs. And of course, not all the networks need to be independent. Usually, larger networks will need the independence, including like large enterprises, universities, like governments, hospitals, etc., etc. And of course, like all the service providers, including ISPs and content providers, are having their own IP addresses and AS number. Next slide, please. Before I introduce the concept peering, there is a very important concept about the network components on internet. This can help you to understand more how we do the peering. We have switch on internet. In fact, it's just a piece of equipment. It works on the so-called layer 2 level. And this kind of switch will allow you to interconnect with different equipment, different computers together through a shorter distance. Usually, it won't go across ocean or things like that. Usually, we will be within a city or metro area. Another important component on internet is called router. It works on layer 3 level. It can help you to go to very, very long distance. And these are the network equipment, network devices which will use the AS number and will use the so-called BGP protocol to help you reach the destination, help you to put your transfer your traffic to the destination that you want to go to. And of course, we have the servers, the computers, which will host the content, host the application that the clients, the end users will use. And this is what we use a lot when we do our work. Next slide, please. And then we come to a concept called transit. We would, of course, connect our end user computer, laptop computer, to our ISP in order to get to the internet. We'll also connect our servers to the internet through our ISP in order to reach the whole world. So they are, the ISP are our transit provider, our internet gateway, and sometimes we call it upstream as well. Next slide, please. And we need to pay them in order to go to the whole internet. And if we want resilience, of course, we may connect to multiple providers. So because we need to pay them, we need to pay a lot, in fact. So larger networks will find a way to bypass them so that we can save costs and also to improve our performance. Because if we connect to a network which we exchange a lot of traffic, then will help us to have better performance as well as possibly a lower cost. Next slide, please. So that's why we would do peering. Because with peering, we can select a more direct path and also use maybe a higher speed to connect to our peers so that we can exchange traffic with low cost, high performance. Let's say, for example, APNIC, we will have servers, and so we want to connect to the networks of our members because more directly through maybe peering, direct peering, so that the users of our service can get to our service more directly. And also, for our office network, we also would like to have a more direct connectivity to maybe services like Google, like eBay, or the rights by using peering. So this is what we want to do in order to bypass the ISP, bypass the transit providers, so that we can achieve better performance. And next slide, please. The networks under autonomous systems will interconnect with one another, to peer with one another, probably at IXPs that I will introduce, and also maybe privately using BGP protocol. This kind of interconnection, this kind of peering is for mutual benefit. As I mentioned, for higher performance, lower latency, lower cost. And usually this kind of peering would have no money transfer between the peers. And if there's circuit involved, the cost will be shared. If we do good local peering among maybe the local networks, then the local to local traffic do not need to route through overseas. And if we can keep the local traffic local, it's very important to the local internet development. And also it will improve the resilience as well. Next slide, please. Well, there's of course private peering, and we actually would do mostly just for the networks that we really have a lot of traffic. If you look at the next slide, if we have like multiple networks to connect, since we can only like have a direct circuit to one network, if we need to connect to like 10 networks together, then in fact we need a lot of circuits, 45 circuits in this case for interconnecting 10 networks. So it's not very cost effective. So that's why we have a concept called Internet Exchange Point. Next slide, please. We use a shared network infrastructure so that the networks can do easy peering with one another. More cost effective, more scalable, especially when we have like many participants. And this kind of like instant exchange can serve different kinds of networks, including ISPs, content providers, cloud service providers, research education networks, government networks, enterprise networks. A simple example, next slide, please, to illustrate how we integrate with one another through the IX. In fact, IX is very simple. It can just be a simple switch in the middle. And each and every network can just connect to the switch. And then through the switch, we can do interconnection easily. Just one connection, and then we can connect to all the other networks on the same exchange. Very simple. But of course, if you only have one switch, then if the switch has issue, the whole the whole network will be down, and then you cannot make use of this path for direct and fast interconnection. Next slide, please. So we will usually introduce resilience. At the very least, we will have another switch so that like our participants, each and every network can connect to both of the switch. And then even if one of the switches is down or one of the circuits is down, then you can still maintain the connectivity. And of course, if you look at the case of ISP on the upper right corner, since they only have one circuit to one of the switches, if that circuit is down or the switch is down, then they will lose the connectivity through the exchange. That's not good. And also another concept is like, if we want even better like resilience, we probably will put the two switches in different locations. So that maybe if one of the location has maybe like fire or maybe like power outage, we can still make use of other location, other data center to maintain the traffic. So this is the resilience for the IXP that we are looking at. Next slide, please. Yeah, the benefits of IXP is to keep the local traffic local. And also allowing direct data traffic exchange, cheaper connectivity, faster speed, lower latency, and of course, more backup paths, so that like when issue with one of the components, we still can maintain the connectivity. And we can also make use of this to help to encourage better development of like local content and local applications, because if we have very high-speed local interconnectivity, then people are more willing to develop content and applications. And it will also help the whole ecosystem, including like maybe encourage more data centers to establish, and also other businesses to be put on internet. Everybody is benefited through this IXP development. Some will gain more, some will gain less, but everybody will gain benefits. And IXP is also considered as critical internet infrastructure locally, regionally, and globally. Of course, they may have with this status, they may have more resources, but of course, it may also mean they have more regulation to govern them. Next slide, please. I do want to use an example to illustrate, the usefulness of the IX. In a lot of Pacific Islands, they are far from any other places. External connectivity is very expensive. They usually have small markets with small population. Usually a few ISP would serve the market, but they usually don't interconnect with one another. Local traffic would usually route through US or Australia. So that's why for those Pacific Islands, local ISP is very, very much needed. And also the ISP should make use of this to do interconnection with one another, so that the internet development can be facilitated. We help BGIX to set the IX for serving the Fiji, internet community. And the first day we set it up, we already observed very much improved latency and also high volume of traffic. And this will help improve the resilience as well. Next slide, please. If you look at the diagram here, you can see before the IXP is set up in Fiji, traffic actually go through US and Australia. In fact, even for traffic between maybe two networks within 10 kilometers, the data traffic still would go through US and Australia. It's a lose-lose situation for both of the networks. But after this IXP is set up, and then two networks can inter-exchange, can exchange traffic directly through the exchange, the latency becomes very, very little. And also, the traffic can be very, very high speed. It was actually, improve the resilience as well, because there are more backup paths. Even the submarine cable has issue, people can still maintain the local connectivity because of that exchange. So it's a very, very good example of the usefulness of the IX. Next slide, please. This is my last slide. The value of and attractiveness of IXP depends very much on, of course, the number of networks connected and also the amount of traffic exchange. The initial period of the IXP development is usually very difficult, very hard, because people would mainly take a wait-and-see approach. They will wait until maybe more networks connected before they will connect. And the market needs, of course, would determine the growth as well. If the market does not have any IXP, the market needs is very high, so the IX would be more attractive. But if the market is very saturated, there are a lot of IXPs already, then of course it's harder. But if they achieve the critical mass, having maybe 5 or 10 networks connected, usually they will attract even more networks connected. And if they initially have only the end users, the eyeballs network connected, they would attract the content providers to connect. And then with more content providers, even more eyeballs connect. Eyeball networks will connect as well. So it's a snowball effect. It's actually very good, but the initial period is usually very difficult. But I might stress that although the setup is very simple, we still need people to maintain a good quality service for the IX so that people can rely on it more. So, good quality service is very, very useful and important to the development of IXP as well. And the last one is, if we have a lot of IXPs in one market, but some may be running very badly with a lot of outages, then it may not help the resilience. We need IXPs which provide good services, stable services, so that everyone can be benefited with good resilience. That's all I have. Back to you, Kenny.
Okay, thank you, Chi-Hu. Just to recap some points that Chi-Hu just mentioned. Actually, APNIC also helping quite a lot of economy in Asia Pacific region to set up their local internet exchange point, and also help them to set up the national computer emergencies response team, and as well as DNS root instance as well. So if you come from certain economies, especially from Pacific Island, please welcome to contact APNIC for looking for that kind of support. Thank you very much. So after 3 wonderful speech, I quickly come up with few questions, probably follow the same sequence as well. My first question would be, since you emphasize the importance of peering and emphasize the importance of collaboration, especially public can improve the resilience as well. Huh? So from your point of view, because of that kind of collaboration there's no restriction, so it's based on market driven. So you are welcome to contact any partner you like and to set up a peering requirement. And what problem or what issue has ever been experienced, and what kind of recommendation you would suggest, starting from Seiichi?
Great question. I manage all of APAC. So I tend to look at each country and see how easy is it to set up peering with the ISPs in that country. There are easy ones, and there are also more challenging ones. And there's not really one easy answer to what makes it more easy or what makes it more difficult, but the ones that are more difficult have several things in common. And I'd like to share a little bit of what I see as challenges. First point that I want to bring up is because we were just talking about internet exchanges, maybe I'll just start with internet exchanges. When there is a successful internet exchange, now the definition of successful is debatable, but if there is a successful internet exchange that is helping to make the local market resilient and providing options to ISPs and content providers on how to exchange traffic with each other, that really makes it easy for us, companies like Google, to exchange traffic with those in the market. But if there isn't a successful internet exchange, that means each ISP or content provider has to build maybe dark fiber to get to each other's data center facilities. That's a lot of work. Internet exchange, as Chief was showing, it's an efficient way to aggregate traffic into something so that you can turn up capacity faster. But if you don't really have that, it's generally slower, takes a lot more work, and it costs a lot more. So that's one aspect where there's differentiation between successful markets and not so successful markets. There is a really good internet, and I think as Chiho was mentioning at the end, it doesn't really mean anything if you have 10 or 15 poorly operated internet exchanges. That's not really helping. So having this successful internet exchange is one aspect of it. So that's one. And maybe I'll just end with the second one. I also see that if ISPs or content providers or cloud providers are limited on what they can do in terms of peering, if there are regulations or laws or customs local norms that limit who we can peer with, where we can peer with, that becomes a blocker to building resiliency, redundancy. And if you have, rules are rules, so you would obey them, but that tends to keep the costs high. It tends to suppress investments into underlying infrastructure like data centers and fiber paths. And that has led to higher costs, less resiliency, less peering, and in the end of the day, it impacts end users. So those 2 points I think I'd like to raise.
Okay, thank you. Noelle?
Yes. So from the Internet Society perspective, one of the emerging challenges that we see is at the moment is really states trying to mandate interconnection, or trying to get into the interconnection space and dictate how networks can connect to each other. You might have heard of this, or you might have seen it as network fees or network usage fees. You might also have heard of this as like a sender pays regime. So how it happens, and this was under discussion in Europe, and until they, on and off, more recently as well. But then the regulators determined that actually, why are you fixing something that? Why are you trying to fix a problem that doesn't exist? In Asia, this has happened in South Korea, for example. So how it works is that the state would say that I am ISP A and Seiichi is ISP B. So if I want to send traffic to Seiichi, I will have to pay him. Or if I'm a content provider and Seiichi is an ISP and I'm trying to reach, well, let's put it this way, Seiichi's customers want my content. So to be able to respond to them with my content or deliver my content to Seiichi's customers, I have to pay Seiichi. And what this does really is first, it introduces barriers to entry. So I think one of the things that we haven't really touched upon is most of the peering, most of the connections between networks happen as settlement free. So there is no fees between us. There's also private peering or paid peering that where there is a fee involved. So usually networks make use of a combination of these of different arrangements depending on what their needs are. So settlement-free peering in principle happens because it's mutually beneficial for Seiichi and I to exchange traffic. But what the law in South Korea, for example, is trying to achieve is that it wants to require paid peering. So it wants to basically put a law down that says, no, you have to pay. And the result of this in South Korea is that it has basically killed settlement-free peering in South Korea. Yes, so a lot of, when it comes to resilience, like relating it back to resilience, you end up with basically how the networks connect with each other becomes hierarchical. And then as a result, you basically get a less resilient network topology.
Okay, right, thank you, Noelle. And Chi-Hu, what's your last comment?
I actually echo what Seiichi and Noelle just said. I think openness is very, very important. For advanced economies, in fact, usually they are more open. Usually IXP would not have, IX would not have restriction for people to connect. And there are like a lot of carrier neutral data centers which allow multiple carriers to set up fibers to their like data center, so that people have a lot of choices. And so we see like IXP, IX would have presence in multiple data center, and like we can see like the other way around, that is the IX would be on multiple data center, and then maybe data center will have multiple IXs. And then people have a lot of choices. They can like make their own decision based on their need, based on whatever business need they have. So this is a good direction, I would say, for everybody. And then people can set up the necessary resilience easily. But for developing economies, of course, the situation would be very different. And we don't even see like IX in like certain economies. Even if we see IX in those economies, people may not connect to it. So I think the importance of that would be the major ISP should be more open-minded, because if they do better peering, in fact, it's win-win. It's also beneficial to them. So we need to open-mindedness for ISPs, the network operators in the developing economies. So yeah, openness is the most important part.
Is it all right if I make a comment about what Chihu was just saying? Redundancy costs money. Building more data centers, building more fiber systems, so that you have a resilient infrastructure, costs everybody money. So the industry needs to think about how we can reduce costs in that sense, so that we can build more different paths, different resilient data centers, build better data centers. And this is where innovation, creativity, cooperation will really, really help. What Google wants and what an ISP wants may be something different. But if we understand each other, because at the end of the day, our networks need to connect through peering. So if we can find mutual common grounds, this will help to reduce costs for both sides, help build more infrastructure, and this is how you have better internet for the end users. And by trying to dictate, like, this is how things should be done, then that limits creativity. That limits cooperation. And this is what I was sort of saying, as costs remain high, because you can't work to lower down those costs when your options are very limited. So when I think about neutrality, it's not always like carrier neutrality. I mean, that word tends to come up pretty often in our industry, but it's about, carriers are a part of this ecosystem too. They're a very important part of it. So we need to start talking together and making sure that we have enough redundancy, resiliency. And we both work to think about how to reduce those costs. And the example that Noelle was mentioning about paid peering is, it may not really be going in that direction. It's not really looking at the core of what we want to improve. So this is what I wanted to mention about Chihu's comments.
Okay, right. Thank you, Chihu. Thank you, Seiichi. And okay, my last question, then we'll open to the floor, and that should be a quick question. And what if in a certain market, eventually, if the market is not competitive enough, eventually the peering market become a failure of the market? Under that situation, does the local government need to have intervened that kind of market failure of market, and to exercise the power such as Noelle just mentioned, pay peering or whatever, sender pay policy or whatever, and especially for uncivilized economies such as Taiwan or South Korea? Seiichi, you first.
pass it. Do you go first? I'm going to cheat.
So there are numerous ways for governments to be involved. When it comes to interconnection, mandating something, putting something in law that things have to be done in a certain way is something that we are really, really eyeing. And that goes to when there are the networks that connect to make up the internet rather, and connect to the internet. They have very different networks, very different sizes, very different needs, and having a mandate in place, from our experience, inevitably would limit the ecosystem by which networks can effectively work together and collaborate and connect with each other. There are other ways other ways that governments can be involved. For example, we have had IXPs that were initially funded by governments. We have had governments come in and basically, as I think Seiichi mentioned in his presentation, a lot of the challenges with peering and with internet exchange points is non-technical. So this is where people relations come in. And governments, as a convener, can bring competing parties together and make them see why this is mutually beneficial for them, why it's actually, for each of them even. It can also facilitate capacity building and awareness building so that you get more local expertise to foster participation in peering and internet exchange points.
Seiichi. Thank you, Noelle. That sort of gave me time to organize my thoughts. I think governments play, especially these days with some of the security aspects that I was mentioning, they do have an interesting role to play these days. And also to the point that I was raising about not everybody comes to these parent conferences. Governments and local licensed telecommunications operators tend to closely speak with each other. And what would be nice is if governments understood the challenges of the peering space and encouraged cooperation among licensed operators versus more sort of non-licensed type services like content providers, CDNs, or other types of services. We all play a similar role in the world of peering, and cooperation is important, but more the governments tend to speak with the licensed operators more than non-licensed operators. But if there is a sort of a wider conversation, this I saw in full disclosure, I'm Japanese, so I tend to have my Japanese friends tell me about what's going on in Japan. I think the MIC, the Ministry of Internal Communications, sorry, I may not have said that correctly, but the MIC is attending or being an observer to an industry meeting where various players, ISPs, content providers, cloud providers get together and talk about how to make their infrastructure more resilient, or how to tackle the increasing traffic during the day during COVID. Of course, everybody saw traffic increase because everybody was online, and how do we manage that and how do we operate against that is something that governments can get involved in, lawmakers can get involved in. We learn from each other, and this sort of engagement is something that I think they have some stake in being able to encourage. So encouragement is something that be nice to really see.
Okay, thank you. Chihu, over to you.
This is, of course, my personal view only, and as you may know, actually, I come from Hong Kong, which is an open market, and I truly believe in open markets. I believe in competition. I think deregulation is the way to go. If there's a failure for the interconnection, I think the best way, in fact, is to open the market and introduce more competition. Firstly, we shouldn't have dominant ISP in the market. If you have one big dominant ISP in the market, then you certainly would not achieve what you want to achieve. You need to have a major competitor for that dominant ISP, and so that the market will be like share among more players instead of just one player.
Okay, right, thank you. So we already finished all the discussion, and I'm happy to open the floor. We have 4 minutes left. Okay. Your name and affiliation, please.
Okay, this is Guo Wei, who is the chair of the TWIGF. And for the Kenny's last question, I have several comments. The first comment is the government involvement is a good idea or bad idea. It's based on several of the conditions. The first of all is the government have to really understand what is happening. For example, he mentioned about Taiwan. If you really want the government involvement, the government have to clear interconnection and also what is the difference between the building. Because sometimes they put this together, so it's difficult. And then if they do not have a sufficient knowledge about the difference between the connection and also the building, then they might come out with a wrong policy. Even worse, it will make a disaster, And of course, I know what Kenny is really talking about. Because in Taiwan, we don't have a really sufficient exchange point. And we don't have such an exchange point is because we have a very large telco, They took almost 70 to 80%, and the original is a national carrier, and the government can have a hand on this carrier, And so I think in the very beginning, the people think about, to dealing with this big carrier is difficult, Google is one of it, Several of the ISP have a difficult to talk to this guy, But eventually you find it, the really you need to worry about the resilience is not only depends on the exchange point. For example, if a national carrier like a Zonghua Telco, they can sufficient to diversify the connection point and do it in the building with multiple of the ISP. Well, it's not the best solution as usual in the other market, but at the current status in Taiwan, it might be one of the solutions. So that's just my comment. I just, if you really want a government involvement, really make sure they are going to make a right decision, or you really making the disaster.
Okay, thank you. That's just a comment, not question. So you're not obligated to respond. So anyone want to respond to a question? No. Okay. No one want to respond. Okay. Your name, affiliation.
Jonathan Brewer. No affiliation. My research published at connectedpacific.org shows that in a lot of markets, incumbent carriers are financially disincentivized from peering with anyone. When you have countries, especially countries whose dominant carrier was built through the post office or the post and telecoms office of the government in the past, they've built an extensive domestic network. They've covered areas, covered remote islands, covered remote mountainous territories with fixed infrastructure. And then when challengers come in and build mobile networks in just urban areas, or when content providers come in and just buy connectivity into a single urban area, the incumbent has absolutely no incentive to give away free access to their extremely expensive network because their cost basis is much higher. So my question is, how do you solve this problem without regulation?
Okay, thank you, Jonathan. By the way, Jonathan also is a keynote speaker for APNIC 58 in Wellington. Thank you. Anyone want to respond? Oh.
So this is also something that so the Internet Society is going to be focusing more on how to say markets that have very specific challenges, such as small island developing states, in the next few years. So I don't have an answer for this, but we recognize that yes, we have seen that there are challenges that are specific to very small markets. We're familiar with this scenario a lot from the Pacific, for example. So I'm sorry, I do not have an answer, but this is something that we acknowledge at the Internet Society, that this exists, and a lot of the work that we've done so far are with big markets and developed markets even. So hopefully, with your help, we'll be able to solve this together.
Okay, Seiichi?
I might take this from a more sort of technical perspective. Jonathan, you raised something interesting, but if that sort of like major player in that market is not a tier 1, they have to buy transit too to get to the internet. They have to reach other networks, and that's generally through transit, or they also have to negotiate with someone that's bigger than they are. So this is the interesting part of the internet, in that if you just look at one country, yes, maybe that's like, you have one big really incumbent that's very powerful, and you don't have really too many ISPs. But the internet isn't just like one country. There are multiple players that come in, and everybody is incentivized to make things better for their business, and that sort of leads to interesting conversations. But if, for example, international companies are prohibited from joining in that ecosystem, that becomes much more difficult. So I think the context depends on like how open that country or market is to international competition. This sort of goes beyond the technical scope of like what I usually look at, but that sort of resonates with me in the sense that if the market is generally open, then there are opportunities to make things better. Of course, when it's in developing stages, there are certain inefficiencies. It will come up. But as international and domestic cooperate with each other, they tend to sort of try to resolve things, at least in the technical space. But that's, I'll just leave it at that. But it's not really, I don't think it's the end of the world if you just have one big incumbent. But it is very tough when new players are prohibited from joining in different ways.
Okay, sorry, we're running out of time. Chief, we have 20 seconds. You want to comment?
Yeah, sorry. Of course, I also don't have answer. But since I'm from Hong Kong, and I think Hong Kong is a very good example of the success of the open market. And no single provider has more than 50% of the market. And yeah, I think this may be a good example for others. But it may not succeed in all the markets, but at least it succeeds in some markets.
Okay, right. Thank you. So before we conclude the session, can I invite you to give a big round of applause to all the distinguished panelists? Okay, thank you very much. So the session is officially concluded. Thank you very much.